Hello friends, in this video I'd like to solve the following problem from the Flanders Mathematics Olympiad 1999, problem number 3. We wish to find all functions f and g from the set of real numbers into itself, satisfying the following conditions. First condition, 2 times f of x minus g of x equals f of y minus y. And second, f of x times g of x is greater than or equal x plus 1 for all real numbers x and y. So it's a rather simple problem. Here are my hints. First, set x to be 0 and find f of y. Then set y to be 0 to find g of x. And recall this it's pretty well-known fact about the quadratic function that if we have a quadratic function h of x, ax squared plus bx plus c, where a is a positive number, then our function attains only non-negative values if and only if its quadratic discriminant is less than or equal 0. So give this problem a try and I will see you in just a minute. Alright. So let's call this first equation asterisk and the second one, let's call it triangle. Our condition asterisk, let's set x to be 0 in our condition asterisk. Then we have the following, 2 times f of 0 minus g of 0 equals f of y minus 1 y. And notice that that number right here is just a constant. We can call it c. And we see that for every real number y, f of y equals y plus this constant. Alright. Now let's set y to be 0 in our condition asterisk once again. Then we have the following, 2 times f of x minus g of x equals f of y minus y. But y is 0, so f of 0 minus 0. And notice now that by our condition, this right here, f of y or f of x can be replaced by x plus c. And also notice that f of 0, what is f of 0? F of 0 is exactly c. Alright, so g of x, pretty easy to see that g of x equals 2x plus c. So maybe let's also write it. For every real number x, g of x equals 2x plus c. Right. So we have essentially solved our first equation. It's very easy to verify that these functions satisfy the first condition. And now let's move on to our last condition. So our condition triangle takes the following form. F of x, but f of x, as we know, it's x plus c, times g of x, which is 2x plus c, should be greater than or equal x plus 1. So it's 2x squared plus 3cx plus c squared is greater than or equal x plus 1, or 2x squared plus 3c minus 1x plus c squared minus 1 should be greater than or equal 0. It's a quadratic function, with this term being greater than 0. Let's compute the discriminant of this function. Quadratic discriminant, it's 3c minus 1 squared minus 4 times 2c squared minus 1. So it's 9c squared minus 6 times c plus 1 minus 8c squared plus 8. So it's c squared minus 6 times c plus 9, which can be written as c minus 3 squared. And notice that for every real number x, f of x, g of x is greater than or equal x plus 1, it is equivalent to saying that our quadratic discriminant is less than or equal 0. Well, notice that it is greater than or equal 0, because it's a square. So that holds if and only if c equals 3. And now we have our explicit formula for f of g. So f of x, g of x, f of x, let's go back, f of x, it's x plus c, and the g of x is 2x plus c. For all real numbers x. And that are our solutions. Again, you should verify. Well, the second condition has been already verified because we have equivalencies, but you should also verify the first condition. So maybe let's do a verification. Verification is very straightforward. The left hand side, let's verify only the first condition. On the left hand side we have what exactly? Take a look, I don't remember. We have 2f of x minus g of x. 2f of x minus g of x, which is 2x plus 3 minus 2x plus 3, which is 3. And on the right hand side, we have f of y minus y, with y plus 3 minus y, 3, exactly the same. So it has been verified, and we have just one pair of solutions. And that closes our problem. So thank you very much for watching. I hope that you've learned something new this time, and I will see you next time. Goodbye.